peak that happens during that time of that time of year. Now, if I am the CEO of that company or whoever is in charge of like purchasing these servers, then I have to think about like, all right, how many servers do I actually need to make sure that we have enough compute power to serve all of these different requests that we have during our peak season, right? Now, in traditional infrastructure, that would mean that you would need to buy those computers, right? You would need to go and buy them. You need to order them. You need to set them up, right? So you need to have cooling for them, power for them, and then you would need to install all the servers or all the actual the actual engines that you would need to run those things, right? I'm actually gonna. This will be easier if I could like draw this. So what I'm gonna do.
Stop sharing my screen.
Yeah.
Stop sharing my screen.
All right. So then let me share my screen. All right. So in a traditional compute environment, we would have like, let's imagine that this is the data center. So we would have to buy the physical server. And then once we bought the physical server, we would have to, number one, there's costs related to actually powering that server. There's going to be costs related to cooling that server. And then in addition to that, let's imagine that we need maybe 1,000 database servers, right? So then we would need to actually install the database engine, right? And then in addition to that, then somebody would have to manage like updating that. So Windows comes out with an update, right? So whatever your operating system is, you're going to have to update that. Whatever your database engine is, you're going to have to update that, right? And then there has to be somebody who is actually then creating what we would call like the administration layer. And then on top of that, we would have like what we would call like the application layer, right? So like when you have a database, for example, people need to access it. Workers need to access it to actually be able to administer it. So we would have to add an application layer that then basically also is like another layer that needs to be managed. So this is how that would happen in like a traditional setting. So in a cloud computing setting, essentially what we're doing is we're saying, instead of you managing all of that yourself, we're going to let you rent our data center space, right? So remember that problem that we were talking about, Amazon? So Amazon has peaks, but then what happens when they're not in the peak season, right? So they just bought 200,000 servers so that they could make sure that they could have, so that they could make sure that their servers wouldn't crash whenever there is a peak. But then for the 80% of the rest of the year, those servers are just sitting there idle, right? So they're just wasting money. And so Amazon is actually one of the, I would say like the inventors of cloud computing, right? Because they noticed this problem. So they noticed that, all right, we are buying massive amounts of servers so that we can take care of these requests that are happening globally, basically for a month and a half a year, right? And then the rest of the time, so from January to, let's call it October, these servers are just sitting there doing nothing because we don't actually have the demand that's required for them. So what do we do? And so what they decided is, well, let's start renting out space, right? Like there are other companies that likely have the same exact problem where they have these peaks and valleys in terms of usage, right? Because every industry will have like peak seasons. Think about even like the NBA, for example, right? So, or a streaming service at this point, right? Like they are going to see peaks during certain times of year, right? It could be they're broadcasting the Super Bowl. All of that's being done through the internet at this point, right? Whether it's the Super Bowl or some other live event, it's the Beyonce concert or whatever is happening, right? Like all of that's happening through the internet, and it requires a whole bunch of compute power to do. But then when you're in those moments of like normal activity, if you were buying servers like you would in a traditional scenario, then you would just be wasting a bunch of money, right? And so essentially what all cloud computing really boils down to at a very simple level is instead of me buying my own servers or instead of you buying your own servers, you come to me and you rent space, right? And then we have a software layer that we call a hypervisor that basically sits on top of our servers. And what that allows for you to do is to like consume that compute power in an on-demand fashion, right? Um, and you only pay for what you use. So what does that actually, what's the benefit of that to a customer, right? Why does that matter for you? A couple of different reasons. So number one, you're able to take advantage of what we call economies of scale. So Amazon companies like Amazon and Google are buying, I mean, probably millions of servers year over year, right? And because they're buying millions of servers, that also means that they are getting bulk discounts. It's the same thing as like you going in and buying like one pair of shoes or one shirt, and somebody's like, "Well, I'll charge you $35 for that shirt." But if you tell them that you're going to buy 1,000 of those shirts, right, then you get negotiating power. You're able to get a bulk discount on those servers. And so you're able to take advantage of economies of scale. Another thing is that you also have what we call elastic scale. So again, going back to our scenario of peak season, um, let's say that you have like an unintended peak that comes in your business. In the old way of doing things, like let's say you got a new offer, you launch it, the marketing's really successful, and all of a sudden there are 100,000 people that are coming to your site, but you only had one or two servers that were available to actually like keep up with those requests. Your website's going to start crashing, right? You're going to lose money, right? So in a cloud computing environment, you're able to like scale your computing up and down as you see fit, right? And so that allows for you to be able to scale anytime that you want. And then you're also able to scale globally. So because companies like Google and AWS have data centers all across the world, then that means that if you decide that you want to launch to a new market, maybe you want to launch to a European market, maybe you want to launch to like the African market, then there are data centers already there, right? And that allows for you to be able to launch into a new market and be able to do so in a matter of minutes versus what used to take months, maybe, right? Because in a more traditional scenario, you would have to order the servers, right? And it might take a month before you actually get those servers. And then you have to do everything that we mentioned, right? Like you have to then install the operating systems and you have to install the actual engines and the application layers. And you also have costs that are related to like human resources too. So in this scenario, you need a if we're talking about databases, you need an actual database administrator. You need somebody who's a systems administrator who's going to actually do the networking and all those things. And you have to have all of those in play before you're actually able to get to providing value. So at AWS, we used to have this thing where we talked about undifferentiated heavy lifting, right? So all of these things here don't actually make you money as a business. What makes you money as a business is whatever service you provide, right? So spending all of this time doing like database administration and all these different things actually takes away from like what you're supposed to be there to do and provide value for your customers. So that's pretty much the basics of cloud computing, right? In terms of like what it is, what problem it solves. Um, I feel like there was a little bit of maybe a little bit of a lack of clarity on like what servers actually do. So maybe I'll draw a little diagram for you to maybe just like clarify that. In the meantime, does anybody have any questions? Cool. All right. So let's imagine that this is a website and it's google.com. So google.com, and this is a super simplified version of this, right, is essentially just a computer, right? And on that computer, we're going to have some files, and those will be files.html, right? So HTML is, all of you know what HTML is, right? Played around with it. So this is the language that we use to define like websites, right? But what you may not be, are you all familiar with HTTP and what that is? Some of you know. Okay, so HTTP is what we call a hypertext transfer protocol. So this is actually what defines like how we get things from like other servers, right? And so it is essentially at a base level just a bunch of like simple commands that are get, put, delete, update. And so this is how like we communicate with our servers. So when you type in google.com into your browser bar, essentially, essentially what you're doing as the user is you are putting in an HTTP request that then will go to this server. And then usually in this case where we're just typing in google.com, it is a GET request, right? And so it knows to then go and find that thing and bring it back to you. And that is essentially like, and then one more part that I would add is there is usually going to be a database connected, or there's usually like what we call a 3-layer application, right? Like that's pretty common where you've got like this middle layer. We've got a front end, which is like a website. Then you've got this middle layer, which we call an API. And then you've got this other layer, which is called the database. It's the data layer. And so ultimately, no matter what thing you're doing, whether it's on your phone, whether it is like a website, web app, whatever, ultimately all you're doing is communicating with another server and saying, hey, I need you to grab this thing for me. And then that middle layer will then go and search a database and grab that thing for you and then bring it back. And that's all an application is at a very simple level. But all of those things, every layer requires a server, right? Every layer has its own unique way of communicating, or excuse me, every layer will communicate with each other using this hypertext transfer protocol language, right? So this is the basis of the internet. It's the basis of everything, right? And so when you think about really huge companies or even really small ones, it doesn't make sense for them to go and buy servers to do this, right? And so that is the problem that cloud computing solves. Now, when you think about like the time that we're in with machine learning, um, I'm sure all of you have used ChatGPT and Gemini at this point, right? You're probably using it every single day for your homework and studying and like all those different things. Um, the amount of compute power that it takes to train one of those models is like incomprehensible. You know what I mean? So they call it a large language model. Essentially, what it is a neural network that has been trained on the world's information or whatever is available on the internet. And so it takes a massive amount of compute power to do that. We're talking like hundreds of millions of dollars to train this thing up, right? So you got computers running constantly. that would be almost impossible to do without cloud computing, right? Like it would be impossible, which is why the companies that own large language models for the most part are the big companies that already have the like data centers and the foundation, right? But even if you're not training a large language model, if you all are planning to get into AI and machine learning, which I think all of you should, because there will be, one second, there will be very few like coders in probably the next like 5 to 10 years. You should all be machine learning engineers. If you're going to be doing machine learning, all of that is going to be done on the cloud, right? Like the training the models, the data that is necessary to train the models, all of those things will be done on the cloud, right? The cloud is basically the new default way that we store and transfer data and all those different things. What's up?
Well, I was going to ask like the clouds, like storage, like no storage, but you said people that would do like the large, the micro models,
Yeah,
they need it.
yeah.
Like they need it for what exactly? Like, that was some information kept that you take from.
Yeah, so large language models in particular. All right, I'm gonna try to explain this as simply as I can. All right, so I'm gonna quickly explain what a neural network is, and then this might make a little sense to you. All right, this is gonna be a very ugly diagram, but you'll get the point. All right, so you all know from math, like this is an XY coordinate plane, right? So let's say that I want to teach a computer how to predict housing prices for me, right, based on zip code, right? That data exists, right? So I could, um, there we go. That's not what I wanted. Um, so I could define, let's imagine that this Y coordinate was zip code, the X coordinate was price. Doesn't really matter which one we do it, but like that means that if I had a million points of data, right, that I could plot those all on this graph, right? So a neural network, like if I wanted to define a relationship between those points, do you know how I would do that? No? So you use like slope intercept form, right? Like y equals mx plus b, right? So I could basically create a line that then defines a relationship between all of these different points, right? Like I could say like given, and then what that relationship does is it allows me to then say like, all right, given a point X on this graph or a point Y, we could then predict what the other was, right? So if you give me a Y, now that I have this line, if that line correctly represents that relationship, if you give me a Y, I can find the X. If you give me the X, I can find the Y, right? So at a really core level, all a machine learning model is like a bunch of data points that you give it over, and then what it will do is it will like learn the relationship of all of those different points, right? And then it will like create a line that fits that and then like test itself and kind of like basically get to a point where it finds an equation that accurately represents the relationship between all these data points, right? But I'm giving you like baby level example, right? So these are called parameters. Those X and Y's, like in the machine learning world, those are called parameters, right? Um, GPT-4 has like a trillion parameters. You know what I mean? So imagine like instead of just like this is bivariate, right? This is X and Y's. Imagine instead of just X's and Y's, we've got a trillion X's and a trillion Y's, right? So in order for the computer to learn those things, well, so the data has to be stored somewhere, right? So yes, cloud computing is like there's no one data center that is large enough to store that much data, right? Like in one physical location. and then the compute power that it actually takes for the computer. So everything that we're doing, right? Like this computer sitting here and running right now requires power, right? You ever have so many tabs open on your computer that it start like the fan starts going, and you're like, bro, this is about to blow up. You know what I'm saying? So like it's taking like because you're doing really intense things on your computer. So like the more intense things that you're doing with your computer, the more compute power it takes to actually do that, right? And so this is where we get into like RAM and like your actual like the actual hardware of your computer, right? And so you need more intense hardware that is able to do more intense calculations and more complex things and do that over an amount of time. And there's no one computer that does that, right? And so the way that we solve that, like at a base level, right, like is I could connect these two computers and they could work together in parallel. Well, imagine that at a million times the scale, right? So now we can have a million computers all working on one thing in parallel that is only possible through cloud computing. Does that make sense? Cool.
Well, thank you for bringing up the issue of large language models.
Yeah, yeah.
I guess my question is, there's now conversations about companies that are providing large language models on like an open source level.
Yeah, like DeepSeek, if you've heard of that.
So it's the interaction between like running model weights on open source level and cloud.
Yeah. So they're related, right? So like all right, so to go maybe like one step deeper into like what a neural network is or like what are the components of it, there are these things called like weights and biases, right? So ultimately like the way that this model will get to like the way that it actually gets to the way that it finds the right equation of all those data points that we've been kind of talking about is it's sort of like testing itself. So it's like running mathematical equations and like figuring out. So there's basically like test data, right? And then there's so like it'll say, all right, I think the formula is this thing. And it's got this test data there. And then it says, like, all right, I'm gonna guess. Like it's got test X's and test Y's. So you'll give it like some test X's and it already knows the answer. But like it'll kind of guess and say, like, all right, what is the guess, right? Like based on this formula that we've created, here's what the Y should be based on the X, right? Was that the actual Y? If it wasn't, then it'll kind of like recalculate what the formula should be. Which is how we would do that, but it's just doing it really, really fast, right? So like that calculation and the ultimate like point that it comes to where it's figured out like, okay, this is the best fit like for this particular problem. That's called like weights and biases, right? And so what I could do or you could do or anyone could do is like the weights and biases, like the way that like the software of like neural networks works is like I could take those weights and biases and basically like copy them. And then I could retrain that neural network on a different set of data, right? Which is called transfer learning. So we use that all the time, right? So like let's imagine that I don't know, you want to create software that you want to create a model that like could be used in self-driving cars to identify like people so you don't hit them, right? Well, there's likely already a model that is like 85% of the way there. You know what I'm saying? And so you could go and find that model open source, and then you could take those weights and biases and essentially it's a fancy way of just saying you can copy that model, right? And then you could then retrain that data on a different or retrain that model on a different set of data to make it fit your use case a little better, right? And so when we talk about like open source models, that's really all they are, right? It's people sharing the model itself, which is a software abstraction, right? Like once it kind of finds a fit, you can then like freeze it and then like make a copy of it and then you can share it on GitHub and stuff like that. And people can then like train it, right? Now, how does that relate to cloud computing? The way that you're actually going to like the way that they're going to store and share that model is on the cloud, right? Like GitHub is underneath all of that, the cloud is where they're storing all those things. Um, yeah, when you retrain that model, the data is likely going to be on the cloud, right? Like all that stuff is like you're not storing it on your computer, right? So if you've ever used like GitHub, if you've ever used like digital, what's that thing called? Digital Ocean, something like that. Anything where you're creating a server online through some type of user interface, you are essentially using the cloud already. They're abstracting certain things from you and making it like easy for you to use, basically. You had a question, John?
I want to ask more about the cloud.
Yeah.
Actually getting started in the cloud, it's a cloud engineer.
Yeah.
So what's like your idea of getting started more in the field and I've seen your learning journey apart from teaching a course like
Yeah. Um, so I think the best way for you all to like make sure that you understand the cloud, like do these courses, right? Like I think the courses are going to give you a really good foundation, but then start building projects, like start building things, right? Um, yeah, make sure that you understand the problems that like the cloud solves and then start building stuff, right? I would start with something super simple, like deploy a website. Um, and then take it a little bit further, right? So once you deploy the website, then say like, all right, well, how would I deploy my own web application, right? So that goes back to what we were talking about earlier. You know you're going to need a database. You know you're going to need an API. You know you're going to need a front end, right? So start just building stuff, and it's going to be confusing at first, but then every single question that you come across, like once you find it, think of it like every time you have a question and every time you get stuck on something, every single person before you has gotten stuck on that same thing. And then once they find the answer, they never have to ask that question again, right? And so building is really the way that you're going to learn. Take as many courses as you can, but don't get too caught up in like, I find that sometimes like we take courses and we take courses and we take courses and then we read books and then we read books and then we read books. Just start building stuff and breaking things. That's literally the only way you're ever going to learn. And I would add to that, make sure that you are leveraging generative AI for all those things, right? Like so at this point, none of you should be coding anything from scratch. You know what I'm saying? Because that is literally the reality. Whether I mean, your teachers are probably not going to tell you that this is not the real world, right? Like when you get out into the real world, nobody is coding anything from scratch. 95, 99% of the things that you want to build have been built by somebody who is smarter than you and has way more experience than you. Don't be stupid and not use what they've built to build things because chances are it's already been built. Nobody, I work at Google, nobody is coding anything from scratch. We weren't doing it 10 years ago. We're absolutely not doing it today, right? Like use generative AI, use Chat GPT, use all those things because they are tools to your advantage. Your job as a software developer or a cloud engineer is to ship product, right? Like it is not to enter things on a keyboard. Don't confuse the two. Your job is to ship product, right? Your job is to ship software. 30 years ago, a mechanic's job was to go and use his hands and like diagnose things. And then cars became computer based, right? And his role changed. It didn't mean that a mechanic disappeared. A mechanic became an operator of a machine, right? You all now are operators of a machine. Your job is not to sit, like you will do some coding, but this is just a user interface. The keyboard is just a user interface. Your job is to build things that work and make money for you or for other companies. Don't forget that. Yeah.
just don't grab into just get into us. I can see applications right now. And get into the shoes.
Yeah. Any other questions? I'm just kind of up here, so anything y'all want to ask, even if it's not tech related.
No, So more I get on with cloud skills.
Yeah, absolutely. Okay. Yeah, so the Cloud Skills Boost platform is really just a combination of like it's really just courses on different things. I'm actually going to go. So I'll maybe talk about the labs a little bit, but it's pretty self-explanatory, right? So essentially, what Cloud Skills Boost is a platform that's going to allow you to learn about different cloud fundamentals. Um, and then they have like hands-on. These are really, really valuable. I use them all the time. So like my team builds these. We build like custom labs and stuff. Uh, but ultimately, they're just tasks with activity checking. And essentially, what it does is it allows you to play around inside of the Google Cloud Console and build different things. What I would like to talk to you maybe a little bit more about is like what is inside of Cloud Skills Boost and like how I'm using it and how you should be using it, like as people who are trying to learn different things. So some of these things that I have on here are kind of internal only, but remember when I was telling you that my role is essentially to go into a customer, they have a request, uh, and then I have to like basically create custom training for them, right? I want you all to know that I do not walk into these meetings always knowing the stuff that they want me to teach, right? It is impossible for any person to know everything there is to know about any one technical topic, right? It is impossible for you to know everything there is to know about data, everything there is to know about any any topic or subtopic because all of them are so large, right? So how I typically use Google Cloud Skills Boost is when I want to learn something very quickly, I will come in here and I will like search for it and just find like whatever topic it is, and I will quickly like gather that information, right? So I already have a foundation. So I would say all like start with just your foundational stuff. So make sure that you understand the cloud. The cloud is broken up into a few specific like what I would call like categories. So you have like compute, you have databases, right? You have what we would call like serverless, which is really just another abstraction for the cloud. But make sure that you understand those things at a very basic level. Networking, right? So those are kind of the things that you need to understand at a very basic level. But then once you understand those things, then you can kind of start picking and choosing for whatever your problem use case is, right? Like I'm not a linear learner, right? So you all are adults, right? So like formal education moves it redefines itself at a much slower pace than society actually transforms, right? So the way that you are being taught right now is like, I am going to lecture you, and you're going to sit there, and you're going to listen to me, and then you're going to go away, and then you're going to do some stuff, and then you're going to give it to me, and then I'm going to check it and see if that's actually right, right? That is not how the real world works, and it's not how adults actually learn, right? So the way that adults actually learn is that we learn for specific use cases, right? Like I don't learn anything that is not immediately applicable to me, right? And I mean, you all are in college, you got to play the game, but this is why like people kind of struggle with school sometimes because you're learning things that aren't like actually applicable to you at that particular moment, right? And so if I were you, the way that I would use Cloud Skills Boost is to like go on here and just start like playing around with it and figuring out like what things are interesting to me, right? So somebody just asked about like machine learning and how all that works. Go on here and like take a course, right? Like if it's a little bit too complicated for you, then maybe you need to go to like the step before that. But think about this as like a collection of Google's information when it comes to like building things on the cloud. So if it's something that you're curious about, go in here and find it. There are these things called quests, which are like just a collection of hands-on labs. So let me see if I go into one of mine. Um, so what have I been working on? I haven't been working on anything yet because I've just been working. But there's like these things called skills badges, right? So a skills badge is basically just a collection of hands-on labs. So I use those quite often. And y'all are seeing some things that are deprecated because like I have access to this in a way that you will not, you know. So I have like access to deprecated courses and all that kind of stuff. But essentially, yeah, run through these things, man. Use it to the best of your ability. Be curious, dig around, is what I would say. Um, any other questions? That's it. Yeah, I'll stick around for a bit if anybody wants to talk, but thank you. Like, do the stuff, do the stuff. You know what I'm saying? Yeah, yeah. So I have a suggestion, man. I think